Welcome everyone. Today our AP Calculus topic, brought to you by NeoTutor, is going to cover essential multiple choice problems. These are considered by College Board to be problems that all AP Calculus A/B students should have mastered by the time of the exam. So we're going to go step by step. So what I recommend is that as soon as I post the problem, that you try it yourself first and then check with the video if the answer is right or wrong. Okay, so let's get started. So number 1, and in all these problems that we're going to be doing today, a calculator may not be used on questions. So number 1 says the limit as x approaches pi of cosine x plus sine of 2x plus 1 over x squared minus pi squared is. So whenever you see these limits and you see a fraction, it's a good idea to use L'Hopital's rule and take the derivative of the top and the bottom separately and see if you can do direct substitution to solve the problem. So the derivative of cosine x is going to be negative sine x. And the derivative of sine 2x is 2 cosine 2x because we have to use a chain rule. So the derivative of sine is cosine and the derivative of 2x is 2. So 1 just has a derivative of 0, x squared is 2x, and pi squared is 0. So let's go ahead and see if we can directly substitute now. So we have the negative sine pi plus 2 cosine 2 pi all over 2 times pi. All right, let's go back and refer to our unit circle. So I want to remind you of 0, pi over 2, pi, 3 pi over 2, comma 2 pi. So the points we're going to be looking at are this point right here, which is 1, 0, and this point right here, which is negative 1, 0. And remember that the x is the cosine and the y is the sine. So negative sine pi, so sine is going to be 0, so that's 0, plus 2 cosine of 2 pi, cosine is 1, so 2 times 1, all over 2 pi is equal to 2 over 2 pi, which is 1 over pi. So the answer is B. Okay, so number 2 says the limit as x approaches infinity of the square root of 9x to the fourth plus 1 over x squared minus 3x plus 5 is. So the trick to doing this type of problem when the limit of x approaches infinity or to negative infinity is you're going to divide by the variable with the highest degree or the highest exponent. And if you look over here, the variable with the highest exponent is x squared of x to the fourth or x squared. So let's go ahead and divide everything by that. So we're going to get the limit as x approaches infinity of the square root of 9x to the fourth over x to the fourth plus 1 over x to the fourth. So, and then when we divide the denominator, we're going to divide by the square root of x to the fourth, which is actually x squared. So we're just going to divide by x squared minus 3x over x squared plus 5 over x squared. Now the trick over here is to notice that 1 over x to the fourth, as you substitute infinity or really big numbers into x, 1 over infinity is going to approach 0. And the same thing would happen over here for 3x over x squared, because that's going to reduce to 3 over x. And then 5 over x squared is going to approach 0 as well. So if you simplify that now, you're going to get the limit as x approaches infinity, and then you're going to have the square root of 9 on top, and then a 1 on the bottom, which is just going to be 3. So the answer is B. Okay. Number 3, the graph of the piecewise defined function f is shown in the figure above. The graph has a vertical tangent line at x equals negative 2. It's a vertical tangent line like that. And horizontal tangent lines at x equals negative 3. So there, and x equals negative 1, so right over here. And the question is, what are all values of x from negative 4 to 3 at which f is continuous but not differentiable? So we're going to have to look to make sure that it is continuous and not differentiable. And so a function is not differentiable when it has a vertical tangent or a cusp. So your vertical tangent at -2 is not differentiable, and the cusp at 1. And also we're looking for a place where f is continuous. So this point here, 0, does not work because the function is not continuous at 0. So the solutions would be -2 and 1, which are C. Okay, number 4, an ice sculpture in the form of a sphere melts in such a way that it maintains its spherical volume. So we have a sphere. The volume of the sphere is decreasing at a constant rate of 2 pi cubic meters per hour. That means dV over dt is decreasing or going down by 2 pi. That doesn't depend on the time, it's just a constant rate, so it's just -2 pi. At what rate in square meters per hour is the surface area of the sphere decreasing at the moment when the radius is 5 meters? Note, for a sphere of radius r, the surface area is 4 pi r squared and the volume is 4/3 pi r cubed. So the information that they gave us is dV over dt. So we're going to want to look at the original volume formula first, 4/3 pi r cubed, and then take the derivative of that with respect to time and substitute the -2 pi to see if we can come up with any unknowns. So dV over dt is equal to, so bring down the 3, 4/3 times 3, that's just 4 pi r squared, and don't forget to multiply by dr over dt. And so we know that dV over dt is -2 pi, and then 4 pi, we are also told that the radius, at this snapshot moment, the radius is 5 meters, so once you've taken the derivative, you can substitute that in, and then dr over dt. At this point, we can use the information that we're given to solve for dr over dt. I'm going to come down here, so I'm going to get -2 pi is equal to 4 times 25, which is 100 pi dr over dt. I'm going to just divide by 100 pi, and I'm going to get dr over dt is equal to -1 over 50. Okay, so now the question is asking, at what rate in square meters per hour is the surface area of the sphere decreasing? So we're looking at the surface area. So the surface area, remember, is 4 pi r squared. So if you take the derivative with respect to time, so I'm going to call that dSA over dt is equal to 8 pi r dr over dt. So this is the unknown that we're looking for. Luckily, we have enough information to solve it because we know the radius is 5 meters and we also know dr over dt now. So we're going to get an 8 pi 5 times -1 over 50. All right, so I'm going to cross cancel. That's a 10. So I'm going to get -8 pi over 10, which is -4 pi over 5. And the question is asking, is the surface area decreasing? So we don't have to put the negative there. The decreasing already takes care of that. So the answer is just 4 pi over 5. Great, on to number 5. Shown above is a slope field for which of the following differential equations? So whenever I am given a graph, I always try to look for any trends. If you notice here, you have slopes of 0. Where are those slopes for 0? So I'm going to try to sort of count and label these. So maybe that's a 1, and then this might be a -1. So for y equals -1, it looks like dy over dx is equal to 0, or the slope is 0. Let's see if that helps us, and we can use some elimination to solve this. Now, we know that when y is equal to -1, the slope is 0, so the function must have a y in it. For example, d cannot be the answer because there's no place for me to put a -1 for the y and to get a derivative of 0. So over here, for example, this is the point. 1, negative 1. If I plug in 1 here, I get 4, and the derivative is obviously not 4. So it's got to be something else. So if I look over here at dy over dx is equal to xy plus x, let's go ahead and plug in that 1, negative 1. So I'm going to get 1 times a negative 1 plus a 1, and that's 0. That could possibly be the answer. What about here? 1 times negative 1, and then it's going to be minus a 1, so that's negative 2. Can't be the answer. What about here? So I'm going to get a negative 1 plus 1, which is 0. So it could potentially be A and C. Let's go ahead and take a look at some other point on the graph where perhaps we can distinguish between A and C. So if I look over here, maybe at this point right here, that is the point, well, let's look over here. This point right here, that is the point 1, 2, and it looks like that slope might be somewhere around 2. Let's see which one works. So over here I have 1, 2, plus 1, which would give me 3. That could be right. And over here I have 1 plus 2, which is 3. And as you can see, that doesn't really help us too much. So in this case, I'm going to want to look at something, maybe another point that could distinguish. So if I look over here at this point, which is the 0, I have the point 0, 2, and then the slope is 0. Let's see if that will help us. So I'm going to get 0 times 2 plus 0. That's 0. And this one would be 2 plus 1, which is 3. That doesn't work. So you might have to look at a few points, but you should be able to figure it out by process of elimination. Okay, number 6. Let f be the piecewise linear function defined above. Which of the following statements are true? So limit as h approaches 0 from the negative side of f of 3 plus h minus f of 3 over h is 2. The limit as h approaches 0 from the right side of f of 3 plus h minus f of 3 over h is 2. Or f prime of 3 is 2. So it's a good idea to go ahead and graph this function first. So we're going to have a cutoff of 3. So these are both lines. So what I'm going to do is I'm going to evaluate what the functions are at 3. So I'm going to get 2 times 3 minus 2, which is 4 here, and 2 times 3 minus 4, which is 2 here. So I'm going to have 2 and 4. Now to the left of 3, the value is 4, and it's going to be an open circle, and the slope is 2. So I'm going to go ahead and just graph something that looks somewhat familiar. And then x is greater than or equal to 3. The value is 2, so it's a closed circle, and then it's going to also be increasing with the same slope. Okay, now if you look at this expression, this is saying sort of the derivative or the slope approaches 2 from the left side of this function. So is the derivative 2 at the left side of the function? And that is correct, because this is a line with a constant slope of 2. And on the right side, it is 2 as well. And this is saying f prime of 3 is equal to 2, or the derivative of this function is 2. Well, it looks like, and if you look over here, the slope of this line to the left is 2, and to the right is 2. So since it's 2 from both the left and the right, then the derivative at that point is 2 as well. So the answer is D. Okay, number 7, f of x is equal to the integral from 1 to x cubed of 1 over 1 plus ln of t. So, and then you're trying to find f prime of 2. So notice that when you go back from the function, which has an integral in it, back to the derivative, you're sort of undoing an integral. And if you remember the second fundamental theorem of calculus, you can go ahead and sort of get rid of that integral. The only thing is you have to multiply by the derivative of that x cubed. So you're going to get 1 over 1 plus ln of x. You undo the integral, but you have to multiply by x cubed, which is 3x squared. So here's a trick, and in multiple choice you should be able to use it rather than doing this the long way. All right, so then I'm going to substitute at 3, so that's 3 substitute a 2. 2 squared over 1 plus ln of 2. So that's 12 over 1 plus ln of 2, which is b. Okay, number 8, which of the following limits is equal to the integral from 3 to 5 of x to the 4th dx? And this is testing your knowledge of Riemann sums. So I'm going to go ahead and show you some tricks to help eliminate some potential questions, answers, and then help distinguish what the right answer is from the remaining. The first thing is this number that you're going to be multiplying by right here, that has to equal the change in x, which is b minus a over n. And your a right here is 3 and your b is 5. So let's go ahead and substitute that in. You're going to get 5 minus 3 over n, which is 2 over n. At this point, you'll most likely be able to cross out 2 of these, which is going to be A and C. So it's got to be either B or D. So let's go a little bit further and figure out how to answer the rest of this. So what you're going to do is you are going to find out C sub I, which is going to be A plus K times change in X. Okay, so your A is going to be 3 plus K times the 2n, so it's 2k over n. And then you're going to evaluate at the function. So I'm going to substitute this 3 plus 2k over n into my x to the 4th, and I'm going to get 3 plus 2k over n to the 4th. And that's what you're looking for. That's what you want inside your sum form. So it's going to be D. And remember, then we're going to take all these little rectangles and make an infinite amount of those and add up all of their areas, and the answer will be D. All right, number 9. The function f is continuous for a negative 4 to x to 4. The graph of f shown above consists of 5 line segments. What is the average value of f on the interval negative 4 to 4? So when you hear average value, you should be thinking of the formula 1 over b minus a, integral from a to b, f of x dx. And our a is going to be negative 4, and our b is 4. So we're going to get 1 over 4 minus negative 4, integral from negative 4 to 4 of f of x dx, which is 1 over 8, negative 4 to 4 f of x dx. And so we're going to find the integral of this function by actually looking at the area under the curve, because we have the graph of f here. So I'm going to be looking for this area from negative 4 all the way to 4. So let's go ahead and find that area. The first one is a triangle with the area of 1/2 base times height. The base is 2 and the height is 1. So that'll give me an area of 1. This one right here, this area is 1/2, base is 1, 2, 3, and height is 2. So that'll give me 3. Now the only thing is this is under the curve, so the area is, or the integral to be exact, is actually going to be negative 3. And this up here can be just split up into a triangle and a trapezoid. This triangle is 1/2, base is 2, and height is 2. It's going to be 2. And this trapezoid is 1/2. The height is right here, it's 1. And base 1 is 2. Base 2 is 1. So that's going to be 3 over 2. So let's add up all of this and simplify. So we're going to get 1/8 times, that is a 1 minus 3 plus 2 plus 3 over 2. So 1 minus 3 is negative 2 plus 2. That cancels out, so it's 3 over 2, which is 3 over 16. And the answer is B. Okay, last problem. Number 10. Let y equals f of t be a solution to the differential equation dy over dt is equal to ky, where k is a constant. Values of f for selected values of t are given in the table above. Which of the following is an expression for f of t? So whenever you have this differential equation in the form dy over dt is equal to ky, you should be thinking and solving it as y equals ce to the kt. You've probably done this in class often, and at this point you don't have to really show all the work and separate and differentiate. If you remember this, that when you solve it, it does equal y equals ce to the kt, you can just go ahead and use that right away. And what we're going to be looking for is pretty much c and k. So let's go ahead and use our first value, which is 0, 4, and plug it in to see if we can find one of the unknowns. So I'm going to get 4 is equal to ce to the 0 times k. So e to the 0 power is just 1. So far we've solved that c is equal to 4. Great. So that means we have the equation y equals 4e to the kt. Just looking at this point, I could easily see that it's probably not going to be for sure C or D. Sometimes they can figure these examples, but it's probably not going to be B. I would actually guess A, but let's go ahead and see if we can finish solving it. So we're going to go ahead and substitute 12 for y, 4e to the 2k. All right, let's go ahead and divide by 4. We get 3 is equal to e to the 2k. Take the natural log of both sides. Bring the 2k down. Natural log of e is just 1. So 2k is natural log of 3. Divide by 2. K is equal to the natural log of 3 over 2. And we finally have our equation, which is y is equal to 4e to the ln of 3 over 2 times t, which is right over here as A. All right, great work, everyone. This video was brought to you by NeoTutor, so visit us for the best of online tutoring and test prep. You can call us at 1-888-636-6284 or visit us at www.neotutor.org. And if you like our videos, please click on the subscribe button below and give us a thumbs up. Thanks, everyone. Good luck on the AP exam.